Hey everybody, we are continuing on with calculus here today. We're looking at improper integrals, so integrals that have bounds that go to infinity in particular here. So here you go. So see how we have infinity as our upper bound here for this first integral? So the integral from 1 to infinity of 1 over x squared. All right, so when we do the AP exam, we are not allowed to write infinity as one of our bounds. What we have to do is rewrite this as the limit as something, so like something not x or y, but maybe just b, as b goes to infinity, of the integral from 1 to b of 1 over x squared dx. All right, and then we got to integrate this. So this would be like x to the negative 2. So we get, let's see, this would be x to the negative 1 over negative 1. So this would be the limit as b goes to infinity of negative 1 over x from 1 to b, and then we're going to plug in b, so we get limit as b goes to infinity of negative 1 over b minus negative 1 over 1, so it's going to be plus 1. And now that we have this function here, this is when we can take the limit. So not until after we're completely done plugging in the definite integral do we take the limit. So as we go to infinity, this term here is going to go down to 0, and we just get this one term here, so our answer is just 1. So this infinite limit, even though it has an infinite limit, this area here under this curve is still just 1. So it gets to a point where the area under 1 over x squared is just so small, so close, that it really doesn't make much of a difference. So like here would be like 1, and that's this area here. Just ends up being that 1. All right, let's try another one here. So that doesn't always happen that we get an answer. Oftentimes, we won't get an answer. And if we don't get an answer, we can say it diverges or it goes to infinity. So again, we want to write this as the limit as b goes to infinity of the integral from 1 to b of 1 over x dx. So now we integrate this. So the integral of this is the natural log of x. So we get the limit as b goes to infinity of the natural log of x, technically absolute value, but it's not going to matter for either of our numbers from 1 to b. So this is the ln of b minus the ln of 1, which is 0. So we want the limit as b goes to infinity and the natural log of b, which is going to go to infinity. So we can say that this integral diverges. It goes to infinity. So there is no set area here. That area is just too big. It will be infinite. It's not like this one. It'll be just a little bit bigger. It does look similar to that, though. Like it's going to look pretty similar to that. It's just going to be a little bit higher, and that little bit of extra height means that this area here is infinite. Where in the other one, it was small enough that it was just 1. All right, some more examples. So again, just get used to writing them with, I usually just use the letter b. So we get the integral from 0 to b of e to the negative x dx. We do substitution. We just end up getting e to the negative x with a negative 1. So negative e to the negative x from 0 to b, plug in b, minus plug in 0. So we're going to get 1 here. So we're going to get 1 minus 1 over e to the b is one way to write that. And it's the limit as b goes to infinity. So that means this is going to go to 0, and we just get 1. So this ends up just equaling 1. All right, if we try this guy down here, so another one that we can get is, well, if we have x squared plus 1 on the bottom, that'd be 1 squared. This is arctan. Oh, but I forgot. We got to make sure we rewrite the integral first. Limit as b goes to infinity of the integral from 0 to b. I know it's annoying sometimes, but we got to do it if we want to get those points on the AP exam. All right, so now we can say this is the limit as b goes to infinity of the arctan of x from 0 to b. So we get the arctan of b minus the arctan of 0, which is just 0. So the limit as b goes to infinity of arctan of b. All right, so that limit actually does exist. So tangent goes off to infinity at pi over 2. So we actually end up getting that this is just pi over 2. All right, a couple more. All right, so this one, let's see. First thing we want to do is rewrite it. So it's the limit as b goes to infinity of the integral from 1 to b of 1 minus x e to the negative x dx. All right, now this doesn't have a nice integral. Right, what I probably want to do is integration by parts. So remember we used liate, L-I-A-T-E. Exponential is the last one. Algebraic is right there. So our u is going to be the 1 minus x, and our dv is going to be e to the negative x dx. So the derivative of this is negative 1 dx. The integral here is going to be negative e to the negative x. So we get that, u times v, 1 minus x times negative e to the negative x, minus the integral negative dx times that. So the negatives are going to cancel out, and we just get that. All right, I'm leaving off the bounds and all that stuff until the end. So if we integrate that, we're going to get another minus e to the negative x, like that. So that'll be plus e to the negative x. So now we can say we've got the limit as b goes to infinity of 1 minus x times negative e to the negative x. If I wanted to, I could change that to just x minus 1 times e to the negative x, plus e to the negative x. And then this is going from 1 to b. So if I plug in 1, let's see, 1 there would be 0. So we'll get e to the negative 1 minus, actually, wait, I'm plugging in b first, sorry. Plug in the top first. Plug in b, I get 1 minus b over negative e to the b, like that, plus 1 over e to the b, like that, minus, if we plug in 1, the first term goes away, and I just get 1 over e, like that. And again, we're taking the limit as b goes to infinity. So this one's definitely going to 0. This one's also going to 0, because remember, exponentials are much bigger than linear functions. So the only one left here at the end is this guy. All right, so that 1 over e, and I guess it's negative too. So I guess this goes below the x-axis and comes back up. All right, so we got an answer there. All right, this one, oh boy. So we'll rewrite it. Let me switch colors here so we don't get confused. The limit as b goes to infinity, and here's the trick. We can say it's from negative b to b of e to the x over 1 plus e to the 2x dx. All right, so this is 1 squared. This is e to the x squared. So this is actually arctan. All right, here's our du. This is u squared. This is 1 squared. All right, so what we're getting is the limit as b goes to infinity of the arctan of e to the x over 1, or just e to the x, from negative b to b. So this is the limit as b goes to infinity of the arctan of e to the b minus the arctan of e to the negative b. All right, so as b goes to infinity, this is infinity. This goes to infinity. The arctan of infinity is pi over 2. That one comes up a lot. So arctan of infinity, pi over 2. I want to just write that down somewhere. Arctan as b goes to infinity goes to pi over 2. All right, here we get 0. All right, as we go to infinity here, e to the negative infinity is 0. So this inside part goes to 0. And arctan of 0 is just 0. So we end up getting just pi over 2. All right, always find it interesting with all this stuff, with all the e's, and we're going from negative infinity to infinity, it's just pi over 2. All right, and that's the end of that one. There is one more section of improper integrals, so come on back and see the next one.